Hello everybody, myself Dr. Gavan Singh. I am working as assistant professor at Department of Physics, Deen Dayal Upadhyay, Gorakhpur University. I want to discuss about how to synthesize partially embedded nanostructures using ion beam irradiation. So first point is what is the importance of nanostructures? Metal nanostructures shows fascinating surface plasma resonance property which depends upon the size, shape and environment including interparticle separation. They can also be used in the applications such as in solar cell, nonlinear optics, optical devices and sensors. So, what is the importance of this partially embedded nanostructure? These partially embedded nanoparticles in matrix get protection from some portion damage during their application, and also it is only formed by ion beam irradiation. So, what is the importance of this ion beam irradiation? As compared to LNE, this is low temperature process, so many process may cause uh, defect formation and any other things at high temperature. So it is very useful. So by suitable thin film, we can use only one ion source and form any type of nanoparticle, which is not achieved by this ion source. Uh, if you want gold implantation, then you need gold ion source and different for different type. But in this method, you use only one ion source and create different type of nanostructure. These partially embedded nanostructures can be reused in the application. That is very important for application purpose. You make one sample and use it for many times. So here I want to discuss about one paper which is published in Journal of Applied Physics in 2002. They have created platinum nanoparticle with a diameter varying from 5 to 20 nanometer on silicon dioxide matrix. They have be radiated with 800 kb argon ions and find the depth of embedding increases with the ion dose, and they explain these results on the basis of capillary driven force and ion induced viscous flow of amorphous silicon oxide, and this viscosity arises due to localized defect rather than creation of large melting zones. That's why low energy ion radiation is very important for this creation of partially embedded nanostructure. And recently in 2014, I have published one paper in Journal of Palestine Journal of Nanotechnology, where we have created gold uh, nano structure which are fully embedded. So our aim is to first deposit 5 nanometer thin film on glass, then irradiate with 50 kml, and then we want to analyze with different parameters. And we have found in the conclusion, I want to discuss that embedded gold nanoparticles in glass substrate are obtained by this 550 kV ion irradiation. And in irradiation, you can see that these partially embedded nanostructures are partially embedded, and after annealing you get these nanostructures which are only on the surface, not attached with the uh, surface. That is the main important of this research work, and I want to emphasize one more thing, that here you can only use one ion source for making any kind of nanostructures. That is very important. And I have discussed about all these things. I want to grateful to Professor R.S. Singh, and thanks to Professor D.K. Avasti, who is my mentor in my PhD, and Sunil Oza from IUAC, and GBS Lakshmi, yes, or Abhilash, DC Agrawal, and I also highly acknowledge the low energy and facility, and for Kedar, which is uh, who is very uh, humble and very disciplined person for providing this and it is.